Hey guys, I'm Aaron with Aleeknives. Welcome to my shop. This is episode 2 of the Revolution Grinder build series. In this episode, we're going to take all of our raw steel parts, we're going to prep them, drill them, tap them, and shape them to get them ready for episode 3, where we weld it all together. So let me show you how we're going to lay out all the holes and how to get nice, accurate, precision measurements. And I've got a couple pro tips for you. These are the instructions for the Revolution grinder. You're not going to get your instructions in a 3-ring binder like this. Brian did this for me, and this is a good opportunity for me to do a quick talk about Brian and I's relationship and how this came to be with this collaboration. I reached out to Brian about his product because I really believe in it, and I wanted to put one together for all my aspiring bladesmiths that didn't want to go out and spend a lot of money for an off-the-shelf grinder. And I wanted my subscribers to be able to get into a high quality grinder for less money. And I believe in this product 100%. Brian understands that I'm under strict time constraints in my shop. I don't get a lot of time out here. So he did me a favor and he put this in a 3-ring binder because he knows that I'm kind of a neat freak. So, he put this in here to make it easier for me. This is something that he probably doesn't do for everybody. And also, when I did the unboxing, you probably noticed that when I got my kit from Brian, all of the stuff was already cleaned up and the edges were deburred. He did that for me as a favor, as part of this collaboration. So thank you, Brian. Let's move on. So right here, when you open this up, it's going to give you a list of things that you need to put this grinder together. And this is a good place to start. You get this kit and you're going to want to open it up and see what tools you're going to need. There's where we're at. So you're going to need some sort of welding machine. I'm using a MIG welder. I'm using a Hobart 110 handler, which should handle this just fine. It is only 110, but it should handle this project just fine. An angle grinder with cutoff wheels and grinder wheels. A drill press. I'm going to show you my low-end Ryobi drill press that I have. You could easily use that. I would strongly suggest using any type of drill press, even if it's inexpensive for this project. I think that your quality will go way downhill if you try to put this project together with the hand drill, but it can be done. You're going to need an assortment of drill bits. You're going to need a couple of different taps, a digital level. I don't believe that you need a digital level. Sure, it would be nice, but you do not need this. I'm going to be able to do mine with 90-degree squares, and I'll show you how I do that. A digital caliper, a speed square, a 4-foot straight edge. I don't have a 4-foot straight edge. I'll make do without it. Magnetic angle braces, that's for the weld up. A ratchet set, which I definitely have. A crescent wrench, which I definitely have. Box end wrenches, which I definitely have, and Allen wrenches. So the only part of this that I didn't have on hand were some of the taps and some of the drill bits. Here we are. This is it. That's the whole laundry list right there. These are all, I went out and purchased all brand new cobalt bits because they make your life so much easier when you buy cobalt. So those are all cobalt bits, and these are the 2 taps that you need. That's not much. Even if you didn't own any of it, that's not much. And you certainly don't have to have cobalt. You could get HSS, high-speed steel, but the cobalt definitely cuts this steel like butter. So let's start building, guys. Here's a picture of the different tube steel cuts. It shows all the different lengths. And this is actually fairly important because you could easily get these two mixed up, except for the fact that if you decide to get the weld seams removed, these tubes right here are going to have the seams removed. So it becomes pretty obvious as to which tubes are the main receiver tubes and which tubes are the stanchion tubes that hold the machine up. So these tubes right here will have the seams removed if you purchase that option. Here's those tubes right here. They're slightly shorter than the uprights. Just for perspective, this is an upright tube. You can see it's about 1.25 inches longer than the receiver tube. And I'll show you what I'm talking about here. You can see that right there. That is the weld seam right there. and it protrudes. So what happens is, if this seam's here, then the nesting tube, the tooling arm that slides in and out, will interfere, this weld seam will interfere with the tube sliding in and out. So these guys have already had the weld seam removed. As you can see how it's smooth in there? It's already cut out to allow the tooling arm to slide freely. Let me demonstrate. Here is said tooling arm. See how that slides in and out of there freely? Now let's do it with the weld seam. See how it won't go in? Because that weld seam obstructs the movement of the tube. Now, something else to be incredibly cautious of. When you put this together, the weld seam on a lot of tube steel is in the middle and it isn't offset like these. This is cool that this is offset, but I still think you need to pay attention. A lot of times in this build, you're going to have to drill and tap a hole. It's probably better to orient your tube steel to where if you have to drill a hole in this, that you're drilling a hole through two sides that don't have the weld seam. This weld seam, this part where it's welded, it typically is a little harder than the rest of the steel at the joint. So if you go and drill a hole, your hole could wander, or it could be harder steel because of the weld seam and harder to tap in that area. Definitely be cautious as you're building this. The very first step here is to put two of these together and weld them in three places for your tooling arms. This is the main portion of it. So with that being said, I don't want to put a weld seam on the bottom because that would mean that this is going to ride right on a seam that had to be ground out. And I also don't want a weld seam on the top because I'm going to have a knob here and a knob on the bottom. So I'm going to orient my weld seams to the side. So they're not going to interfere with my slide. So I'm going to get the most optimal slide out of this. And it's not going to interfere with where I have to drill and tap for my locking knobs, for my tooling arm and my platen arm. So let's jump in. Now, some of the locations where you have to drill holes and tap holes are incredibly important. But then again, some of them really aren't that important on where you put them. Like these knobs for tightening and loosening the tooling arms. You want to get them as close to center as you can. And, in this general area, as far back from the front of the receiver tube as you want. This is a good plan, but I don't feel like I need to cut this out and lay that on here for a template. I can easily just make sure that I've got my weld seam oriented in the direction that I want. I'm just going to put a little bit of dicum right there. Make sure that this weld seam is also oriented in the same direction. Right like that. And put a little dicum right there. Right in the same areas. Actually, there we go. That's the areas that I'm going to mark out for these holes that I'm going to drill. When you're looking at these plans, some of these are true to size and meant to be cut out and laid on your piece. Some of them are plans that give you the measurements so that you can take a measurement and transfer it to your piece. This is one of those. You could tell because this is not true to size. The piece is much larger than the picture. So then you just look at the picture and you take measurements. That's why I use dicum on this. It says 25.4 millimeters, 25.4 millimeters. Scribe yourself a line. There you go. And then it says that this right here is going to be 1 inch, which is going to be 25.4 millimeters. That was exactly the same. Right there. And you just do it from both sides. That way you know you're in the middle. Right there. There. There you go. That's good enough. Now we'll go over and drill these holes. This says to drill a 5/16 inch hole, and then we're going to tap it with the 3/8 by 16 tap. Hey guys, real quick shout out to one of my channel favorites here. We have Empire Abrasives, and not only do they supply 2x72 belts that I use exclusively here in the shop, They also supply these wonderful 9x11 sheets of sandpaper. Once I started using this rather than the Harbor Freight paper, I cut my sanding time in half. Definitely go check this out. I'm not just plugging these guys because they help me out here in the shop. I actually love these products and I use them, and I approached them, by the way. Check in the link below. Go to Empire Abrasives. You can enter Aleeknives for a discount when you check out. Safety glasses. A must. I'm going to use a milling machine for this. I've got it all set up. We're ready to go. I've marked out my location. Turn it on, and here we are. And the first hole is drilled. Let's go ahead and duplicate that on the second piece. Where's my chip brush? I was going to tell you a tip, but I can't tell you a tip if I don't have my stuff. All right, guys, you ready for a pro tip? After you drill a piece of steel with cutting oil, don't take your finger and wipe it off. That's a good way to hurt your finger. And our digits are very important. That's what a chip brush is for. Done. I always keep a chip brush laying around to debride my surfaces. Check that. Perfect. Every time, cleaned it off. Kabow. Kaboom. Kaboom. So, these two pieces, drilled, done. Here's another goodie. I found these hand reamers. These things work great. You just jump in there, ream out your hole, and basically it cleans off the top. Here's your chip brush, and we're going to go ahead and tap this. I bought brand new, high quality taps for this project. Da-da-da. All right, there we go. I could have tried to tap this in the Bridgeport, but I don't have a power tapping attachment for my Bridgeport, so I'm just going to hand tap this. So you just run the tap in, back it up. Run the tap in, back it up. And what that does is it clears your chip. As you're running the tap in, it's cutting a small piece of metal out. So each time that you run it in, when you back it up just a little bit, it allows you to clear that chip, and it makes it easier to tap the hole. There you go. Beautiful. And that one is tapped. I like to put my chip brush in there and run the chips off of the tap as it's coming out. There we go. This one is done. Totally done. Perfecto. Next, here is the tracking pillar. Now, it's got the tracking arm that pivots on top of this, and you'll notice that there's a cutout on the front and the back. And what that does is it allows the clearance for this arm to pivot up and down. That's great, but it's not how I'm going to do it. I'm actually going to radius these inside corners with a mill. I'm going to use a large milling cutter, and I'm going to come in and cut down to remove this material until I get to this area right here. That'll give me the clearance that I need, but I'll have nice swooped corners, and I think aesthetically that'll look better. And since I'm building this machine for myself, I'm going to go that route. Now, one thing I would like to definitely point out, these tabs will become extremely flimsy after you remove both the material off the front and the back. So you're definitely going to want to drill this hole first, and that's exactly what I'm going to do. I'm going to mark this out, I'm going to drill this hole, then I can remove the material off the front and the back. We have a hole to drill here to hold the spring tab, and then we're going to cut the bottom of this at roughly a 60-degree angle. You know, if it's 60, 61, 62, 58, as long as it's close to that, you're going to be fine. This isn't This isn't absolutely mandatory that it be perfectly 60 degrees. As long as you get it square from side to side so that the tube sits straight up and down on the chassis, you're good to go. You don't want it to lean left or right, but that's more to do with when you get to the weld up stage. Let's go ahead and do this. What we're going to do is I'm going to mark this out, drill this hole, and then I'm going to mill off the material on the front and the back, and then we'll drill this hole and cut the bottom off. I just want to reiterate, you do not need a milling machine for any part of this build at all. But I have a milling machine and I like to use it. So I'm going to. Here's my 60-degree angle right here, and I'm going to go ahead. I've got it chalked up and marked out, and I've ran the milling cutter across to make sure that everything's right. I'm going to go ahead and mill this off. You could easily take a cutoff wheel and an angle grinder and just cut that off. This will be more accurate, but you could easily do it with the cutoff wheel. You could even do it with the metal chop saw. This is how I'm going to do it. Now it's time to drill the 1/2-inch hole for the spring tab. Now I flip the tube around, put a 3/8-inch drill bit in here, and we're going to drill the tracking arm pivot hole. This hole goes all the way through for a bolt for the tracking arm. Definitely want to make sure that when you're drilling a hole all the way through your stock, that your piece is hanging out of your vise so that your drill bit does not drill into the bottom of your vise. Here's a good tip, guys. On stuff like this where you're doing layout lines, a lot of times guys grab their veneers and they get their measurement set, and then they come up here and they scribe a line. That's great. I do that all the time. Also, you're not supposed to scribe with the tips of these, but I do it on my throwaway veneers. But the problem with that, with this, is these square tubes are rounded over. They have a real nice radiused edge. So there's really no place to get an accurate measurement here, because if you come off to the flat, you're changing your measurement. So here's a good idea. Lay your steel flat and use a height gauge. Come over, scribe your line, and then you get a perfect line, and you don't have to worry about the radiused edge. Just raise your height gauge to the place that you need it and scribe your line. Now I'm going to come in here and remove the meat off the front and the backs. Too deep of a cut. Here's my nice, beautiful part. It came out great. You can see what I was talking about with the radiuses here in these inside corners. Now listen, I was thinking about this. You don't have to have a milling machine to do this at all. You could just as easily drill a hole in the corner and then use an angle grinder and cut your straight lines into the hole and just file it to make it nice and neat. But I have a milling machine, so I went ahead and just ran an end mill right into that corner and out. Now I went ahead and I took a second cut file and just cleaned up all my edges. You know, I think it's good measure right after you get done cutting your part, clean up the edges so that you don't accidentally cut yourself. Yep, get all those edges cleaned up. That part came out perfect. Next up, the two risers. We've selected our riser steels right here. It's the last of the large tubing that we'll need in the build. And we're going to lay these out. We've got a large hole to drill. This is the axle hole for the entire machine to work. This is probably the most important hole to get right on both of these in the exact same location. And the front post on the machine has a locking bolt right here so that as the machine's up, you can turn that bolt and lock it, flip the machine, turn that bolt and lock it. I plan to drill these at the same time. I think what I'm going to do, just to maximize success, is I'm going to lay my two tubes on top of each other, taking into consideration where the weld seam is, and I'm going to tack weld these together and then drill a hole through both of them at the same time. I think that's going to maximize my success. After I get my hole drilled, I'll just take my angle grinder and pop my little tack welds off, and there we go. All right, so I've got my two pieces together here, laid on a flat surface. Everything's lined up. We're just going to throw a quick tack weld on these. And now I'm going to put the weld strategically on the face so it's easy for me to grind off. I don't want to put the weld in here where the metal rounds over because it'll be hard to grind off. I'm going to put it right here on the face. When you move up to larger drill bits, especially something this size, anything over a ½ inch, you definitely want to slow down the drill bit. If you go too fast, you're going to overheat the metal and you could possibly work hard in the metal, ruin your bits, and all kinds of bad things can happen. So your speed and feed rates actually really do make a difference. When you get into these larger bits, it makes even more of a difference. So you'll see, I'll slow this way down. I'll put some cutting oil on it. I've got everything lined up. Let's drill some holes. Smooth as butter. Drilled our axle hole. Got our axle and our cam. We want to make sure that our next hole lands right in the center of this track, which it does. So that's absolutely perfect. We can go ahead and drill on our original mark, and we're good to go. And now we tap it. Go in here, and you want to make sure that you get your tap nice and straight, vertical, both directions. There we go, right there. Cutting fluid. Cutting fluid always helps, right? Little lubrication. Now I still need to radius this corner right here. And the reason being is because you need to offer clearance. The machine's going to pivot like this, and basically the machine comes around this corner. If this corner's here, then it can't pivot. So you need to radius this corner off. We put this hole precisely the same distance from the top from the side. So basically, I used my height gauge to mark the center line of this hole when we drilled it. So that's our center line right here. Now I can stand this up and use the height gauge to mark a line all the way around this side, from one side to the other. And what that gives me, let this focus here, that gives me a grind to line right there. Okay, so I'm gonna take and run a radius. This is really easy, this is not rocket science, from the top to the side. I'm just gonna cut that off. And then what this line allows me to do is make sure that I'm square across here and that it's square from the top here on both sides, to make sure that this is just symmetrical, because I care. This doesn't have to be symmetrical, it's just to cut for clearance. But, you know, I mean, take your time. Build your machine right. It's going to stand tall. People are going to go, wow, where'd you get that thing? And when you tell them you built it, you'll blow them out of the water. All right. Now, you could take this angle grinder and you could cut this excess material off just like that. And I'm going to show you how to do that. That's how you take off the bulk of the material right there. Now we can take and we can, what I did is I cut a little bit proud of my contour lines so that I can go in there and clean it up. I can use a grinding wheel on this. I could use files to clean that up. But I also own two 2x72-inch grinders. So I'm going to use this on one of my grinders. Still continuing ahead with our drilling and tapping operations is the tracking arm. Now the tracking arm has a lot going on here. It may look simple, but there's actually a lot going on here. You have the actual pivot, which is, I've already marked all these out. Here, let's orient this correctly. So we've got the pivot bolt that's going to go through here, and it's not in the center of the arm, it's slightly offset. Then right here we have now this hole goes all the way through and it's tapped on both sides, and this is for the tracking adjustment screw that goes all the way through. And you have a tracking arm that'll mount with this hole on the top. So your tracking arm sits here, and then the bolt goes through it that moves your tracking arm up and down. This bolt back here, all that does is hold the spring. Okay, so I've got all these marked out. Smoky. Ow. One more hole in this bad boy. Now the next hole actually goes all the way through. And this is for the tracking adjustment arm. Clean out my tap. Little cutting oil on there. Like it. And once again, we want that to go as straight as possible. Sometimes it's better to put the tap in your drill or your milling machine or your drill press to try to get it nice and straight. Or you can just eyeball it. There we go. See a potential problem. This tap doesn't go all the way through. Interesting. So, this is one of the circumstances where buying the more expensive tool was a detriment. When you watch the Housemaid video by Brian, he says that he buys his taps from Harbor Freight, and the shank actually tapers down, where this shank is full size. And when you try to tap all the way through the tube, this doesn't poke through the bottom before this shank starts to hit. Pull out the Harbor Freight tap set. And let's see, we're looking 3/8 by 16, I believe. So we pull out the Harbor Freight one. Make sure we're good. Isn't that funny? I made sure that I bought a nice, expensive American-made tap. And it wouldn't do the job. Actually, I believe in buying good tools. But you see, I do have Harbor Freight tools also. You know, I mean, you buy what you can afford. These Harbor Freight taps have lasted me quite a long time. There we go. And it's done. All right, we went ahead and we built the entire tracking arm. Now we're going to build this tracking assembly, which consists of two parts mainly. We've got this part right here and a tab, this part. Now the tab fits right here, and what we have to do is we have to bring these two pieces together. We have to nest this piece inside of this piece, hold them together at the same time, and drill a hole through for this axle nut, or this axle right here. And that's going to allow this pivot motion. This is kind of tricky. The way I set this up is by Brian's instruction. I agree with him. This is a good way to do it. Absolutely. You nest the two pieces together, you put it in the vise, you locate both pieces off of the flats of the vise so that you can guarantee that they're streamlined with each other. You get all lined up and you drill your hole through all the pieces at the same time. I've got everything lined up and I'm ready to rock. I use Tap Magic. Here we go. The last operation on this is to drill this pilot hole out with the 27/64 drill bit. This bad boy gets tapped with a 1/2 by 13 tap. That's a rather large tap. All right, come in, make sure we're square. There we go, looking good. I like it. So these are the last parts that we had to drill. Actually, that one was already done. You guys watched it. What we had left was the two tooling arms. These were very simple. We had one center line, two holes, and these are both drilled and tapped. One goes all the way through drilled and tapped, and one goes through one side. This is the platen arm right here, and this will mount just like that. So that the first one is your mount, and the second one is your pivot hole. Pretty cool, very easy. And this is the work rest arm right here. You're gonna have one throughput bolt, and then you're gonna have one tapped bolt for the work rest to pivot. Everything else you guys watched, I didn't feel the need to show you every single hole that we drilled because it'll get pretty boring for you. But there you go. Couple more holes drilled and we're on our way.